Okay, so we graphed our first rational function here, and the second one is going to be shifted to the right. How many units? 3. And not down to. The fact is there is no vertical shift. Okay? Because it's squared, they're both either above or they're both below. Do you know which one this is? Below y. Because of the negative. The 2 simply creates a vertical stretch, which we really don't show as we graph it. A +3, a +1. Yep, that would create the vertical or the horizontal asymptote to move them up or down. Yep. So therefore, the domain is all x values not equal to 3, and the range is y values that are less than 0. And so you can see from this graph that you can never get a value that's positive, can you? They all stay below the x-axis. So our horizontal asymptote is going to be x is equal to 3. Whoop, I'm sorry. Gosh, I did that again. Our vertical asymptote is going to be x is equal to 3, and our horizontal asymptote is going to be y is equal to 0. The vertical asymptote is this line right here. It's an equation of x equals 3. The horizontal asymptote is this line here, y equals 0. Yeah. So the range is all the values that the graph can output, and it can output down here, 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 here. Got it? Try the next one. What's that? Because you can get values that are negative, but not positive, right? Try the next one on your own. For those of you who were not good at it the first time, we'll make sure that you're excellent at it the second time. Yo. Sure, these are the Karate Kid functions. I don't know. That should be the shape of your graph. Domain is x can't be 0. Range is y cannot be 3. So your vertical asymptote is x is equal to 0. And your horizontal asymptote is y equals 3. Lauren, can you share with us the mistake you made so we can learn? Oh, you just wrote it wrong. Got it. Good thing we have an eraser, huh? All right, let's do the next 2, and then I'm going to set you off to work on your own, and you're going to see a little bit about what you're expected to do. So look at this one, -1 over x minus 3 to the 5th. Oh, no, it's to the 5th power. The fact that it's odd is going to be, yes, to the 1st power. Very good. So it's going to be shifted to the right 3. And it will be flipped upside down. Because of the stupid negative. Whether the negative was on the top, outside, or in the denominator, it's a vertical flip. I don't know. That you could write -1 over 2 as -1 over 2, or 1 over negative 2, and either way, it has a negative on the outside, right? So, no, it's okay. Thank you for asking questions. What is the domain? Range. Y not equal 0. You have a vertical asymptote of x is equal to 3 and a horizontal asymptote of y is equal to 0. Now, we're going to switch things up just a little bit for the next one. Are you ready? Very good. That's not how we're going to really switch things up, but we will put that down because it was an excellent thought. Thank you, Michael, for sharing. You are 100% correct. But that's not what is going to shake things up for us. I'll show you in a second what we're going to do that's slightly different to try to help you anticipate what we're going to do later on this unit. Because as you notice in this lesson, this is all information we've had before, right? You know that there's something more that's coming, right? One thing that we like to talk about with these type of shapes is the X-Intercepts. As you notice in this past section, we've been talking about the rational root theorem, which involves finding the X-Intercepts. And so I'm going to find the X and Y intercept for this graph before I actually sketch it. Now, because you know what the parent function looks like, it's either going to be on the top and bottom and then the top or the bottom. So which does it start out with here? Top or bottom for the graph? Bottom, and over here, top. So that's what we know. But we're going to find a couple points, and you're not going to have to do this with the rest of the worksheet. The rest of the worksheet is going to be nice and fast. I'm not even going to have you find the domain and range in the rest of the worksheet. I'm just going to have you sketch the graph. But let's find the X-intercept and the Y-intercept. The Y-intercept happens when what is equal to 0? When x is equal to 0. So I can find the y-intercept by simply plugging in 0 for x. If x is 0, I get negative 1/3 plus 2, which will be 5/3, right? Everybody okay with that? If I plug in 0 for x, I get negative 1/3 plus 2 is 5/3. So what that means is I know that this graph crosses the y-axis at 1.667. So I'm going to put that dot on my graph. You okay with that? Now I'd like to find the x-intercept. The x-intercept happens when y is equal to 0. So if I set y equal to 0, 0 equals 1 over x minus 3 plus 2, how would we solve that? You could multiply through by x minus 3, or subtract 2. Negative 2 over 1 is equal to x minus 3 over 1. I'm sorry, 1 over x minus 3. I plugged in 0 for x, and when I did, I got 5/3. What do I do now? Cross multiply, I get a negative 2x plus 6 is equal to 1, or negative 2x is equal to negative 5. So x is 5/2. And so on the x-axis, I will plot 5/2, which is 2.5. Now, you told me from the very beginning that this graph would start in the lower portion. And then, does it cross the x-axis over here? No. So it would have to be in the upper portion, correct? So I know that you already knew that was the shape. But what I wanted to do is show you something that we're going to learn later on to help you out. What I want you to do right now is I want you to take about 8 minutes, and I want you to work through the rest of these problems. You do not need to find the X and Y intercepts. You do not need to state the domain and the range. You do not need to state the horizontal and vertical asymptotes. Just sketch the shape, and the answer key is right up there, and then we will get to the new part of what your assignment is. We want to wrestle with this just for a little bit. So as you need help, raise your hand, and I'll be on my way to help you. Note you're going to have 5 problems from your book. Okay, here we go. Now go to your notes. And on your notes, I want you to turn to this page right here, the very last page that you have. I do have one mistake on here. Instead of a +5, it should be a -5. Sorry. Yes, note sheet. Very last page of your notes. Now, what's different about these? For YouTube, they said that there's more space for the problem, so they must be more difficult. There's an X in the numerator, right? Yeah, so exactly. Yep, so we got a few people answering correctly. So that's going to create a challenge for us. And what I'm going to do in this situation is a couple things. Number one, I am going to identify the X-intercepts and the Y-intercepts, and I'm going to show you a super quick and easy way to do it. First of all, the Y-intercept, again, we plug in what for what? Plug in 0 for X. So if you plug in 0 for X, you get 0 over 3, which is 0. Okay? Second of all, if you want to find the X-intercept, and this is where you need to focus. Otherwise, you will not see the whole trick. Are you ready? I set Y equal to 0, correct? So 0 equals X over X plus 3. How would you solve that? Cross multiply. When you cross multiply, what happens to the denominator? It goes away, and you end up with the top equal to 0. So what we have learned is this. If you want the entire fraction to be equal to 0, just make sure that the top is equal to 0. Where would X be equal to 0? At 0. Watch, I'll show you another example. X minus 1 over X plus 4 is equal to 0. Anybody know what number satisfies that equation? 1. It's wherever the top is equal to 0. If you don't like that, watch what happens if we cross multiply. You get X minus 1 is equal to 0. Right, so you could just look at where the top is equal to 0 to find the X-intercepts. That's a quicker way of trying to think about it. So the X-intercept occurs at 0 as well. So what we know is that this graph goes through the origin. Sweet. Second of all, I would like to get a visual of what this graph looks like. Only my college algebra teacher never taught me how to graph stuff with X in the numerator. So what do? Well, we use our star quality of problem solving, and we take X plus 3 and we divide it into X plus 0. No calculators on this test. What do you multiply X by to get X? 1. X plus 3, subtract, and we get -3. So if I were to write this, I would get 1 minus 3 over X plus 3, correct? Or you would maybe prefer to see it as -3 over X plus 3, plus 1. Does that look familiar? It's just what we practiced for 10 minutes, right? So I took something that we didn't know how to do by simply rewriting it by using division. We can now graph that. That's a piece of cake to graph. We move to the left 3, and we move up 1. You flip it since there's a negative. I know that because we plotted this point here, that it's going to be in the lower part over here. And I know it does not cross the x-axis over here, so it has to be in the upper part. So even if you forget what the graph wants to do by locating an x and y intercept, it tells you how to solve, right? Isn't that nice? Let's try another example that's going to work out very similar. So I will first look for the y-intercept. The y-intercept I get when I plug in 0 for x. When you plug in 0 for x, what do you get? -4. Very good. So you get 4 divided by -1. If I want to find the x-intercept, I simply have to look at where the top is equal to 0, which is 4. So already I have a heads up on this graph. It crosses at 4 and at -4 for the y-axis. Sweet. Yo. I have a -4. The y-intercept will happen when x is equal to 0. So if you have 4 minus 0 divided by 0 minus 1, we have 4 over -1. Better? So now, in order to get the rest of the graph, I will divide this. And as I divide it, I'll have x minus 1 goes into -x plus 4. What do you multiply x by to get -1? -1. I have a -x then plus 1, and I subtract. I took the 4 minus the x and I rewrote it. I subtract and I get +3. So I have a -1 plus the remainder of 3 over x minus 1. Otherwise written as 3 over x minus 1 minus 1. Do you know what that shape looks like? Vertical asymptote at 1. Horizontal asymptote at in this case, the dots really help me. It tells me that I will be in the lower portion and then the upper portion. Isn't that nice? Are you ready for a little bit of an aha moment? Shifted to the right 2, correct? Shifted up 3, correct? So would you agree that this graph basically looks like this? Okay. That means that as I am way over here on the number line, on the x-axis, the graph is still approaching a value of 3, right? I mean, for most of this graph, it looks like the line y equals 3, right? It looks like that all of the time, except for one little spot. All of a sudden, it runs into x equals 2, and all chaos breaks loose, right? But then as it finally gets past 2, then it's like, oh, great, I get to be like 3 again. And it just continues on that way until it gets to infinity, right? If you approach from this side, it's like, oh, great, I get to be 3. Then all of a sudden, when it gets to 2, it just blows up. It gets past it, and it's like, okay, life is good and normal now, right? Watch what you have for your graphs. This graph wants to look like 1 all of the time, right? This graph wants to look like -1 all of the time, right? You'll see how that plays out now in our next example. Let's find the X-Intercept. The X-Intercept we find by setting the top equal to 0. Top is equal to 0 at, it factors, I have x minus 5 times x plus 1. So X-Intercepts of 5 and -1. I have a Y-Intercept. I plug in 0 for x, and I get -5 over 2. Yep, -5 halves. I can mark those points. I switched this to a -5, so it would factor. So as you plug in 0, you get -5, and 0 here, you get +2. Okay, if you plug in 0, 0 minus 5 is -5. 0 plus 1 is 1. 1 times -5 is -5. Okay, then let's do this. Let's look at x squared minus 4x minus 5. If you plug in 0, you get 0 minus 0 minus 5 is -5. Zero on the bottom. 0 plus 2 is 2. We good now? All right. Okay, so we've got x-intercepts of 5 and -1. +5, -1. And we have y-intercept of -5 halves. What about there, huh? Now, let's divide it. X plus 2 goes into x squared minus 4x minus 5. What do you multiply x by to get x squared? Multiply it back through x squared plus 2x. Subtract -6x minus 5. -6, very good. So a -6x minus 12. Subtract those and we get 7. So you have x minus 6 plus 7 over x plus 2. Or 7 over x plus 2 plus x minus 6. Look back at our work. This one wants to look like y equals 1. This one wants to look like y equals -1. This one wants to look like x minus 6. What does that look like? It's a line with a slope of 1 that passes through -6. Yeah. It wants to look like this. So we don't have a horizontal asymptote. We have a line asymptote. Your book calls it a slant asymptote. You could call it a line asymptote. You could call it end behavior, which is the term I generally use, but that's what it wants to look like. It doesn't, because this stupid -2 value just makes it blow up. But I have a vertical asymptote still at what value? -2. So it's going to sit in the top or the bottom here, and it's going to sit in the top or the bottom over here. So over on the right side, does it sit in the top or the bottom? It sits in the top. You got 3 dots up there that tell you, right? And it's going to follow close to the asymptotes. But it's also going to pass through the points. Now, over on the other side, on the left-hand side, it's either going to sit in the top or the bottom. Which one is it? Why? Does it cross the x-axis here? No. So it can't be in the top. It has to be in the bottom. If it was in the top, it would have an x-intercept up there, and it doesn't. So that's a rational function that looks a little bit different. It's totally cool. It's fun. It's exciting. You can save your enthusiasm for tomorrow and then just let it all out. No, you don't have to finish writing the intercepts. Your assignment for your final assignment, your worksheet says, or your homework cover sheet says 9 and 10, 25, 26, 49, 51. I took off 9 and 10. Simply do 25, 26, and then 49, 51. There's just 5 problems. Find the intercepts and sketch the graph. That's going to be your instructions. And tomorrow's a full work day. The study guide is posted in my room. I have extra copies. It's a great day to do mathematics. I think that it's online. If it's not, let me know and I'll post it online. And remember, my chicken thighs? Chicken thighs are great. Those were in the crock pot. Crock pot worked out fine. It was the oven that broke. So that was a little trickier. Yeah. So I'm going to my website. Let's see what we got here. We got college algebra. And we've got chapter 3. We got study guide answer key right there. Woohoo! Assignment right here. Boom. Later, YouTube.